some physical science problems for KSET 2020 paper. So the total number of questions will be 100, and for 200 marks each question carries 2 marks. So here the first question: identify the vector that is perpendicular to both I plus 2j I cap minus 3 cap and minus I cap plus j cap minus 2 k cap. So the correct answer, if you do the calculation, the option C is going to be correct. If I dot I minus 1 plus 1, 5 into 2 10, 3 into 3 minus 9. So if you do, that must be equal to 0, and if you multiply these two vectors, then that value must also be equal to 0. Plus 1 5, 3 into 2 6. Okay, so that means the correct option is C. Vector A is equal to 2i I cap minus x square y j cap. The value of A and phi has been given. Just using this formula and put the values x and y, 1 and 1. First you should do the derivative of del phi. After that just multiply with that vector A. If you substitute, the value you are going to get is 6. The value of the integral minus infinity to plus infinity d by dx delta of x e to the power I kx dx, where k is constant, delta x is the direct delta function and which is given by. So we need to find the value of this delta x so that the answer must be a constant. So here the correct option is D. Okay, minus ik is the correct value, so that you will get the answer k. The two independent solutions of the following differential equation, just you can consider d square y by dx square as d square plus 3d plus 2 is equal to 0. Then algebraic formula like that you can make here splitting of 3d 2 into 1 you will get. So the two independent solutions for this question, the answer is option A, minus x minus 2x. Just you can easily get here from observing the equation. The number of independent components of a real asymmetric tensor of rank 2 in 4 dimension is. So as we know 3 dimension, but they are asking 4 dimension number of independent components of a real asymmetric tensor of rank 2. Then the answer is 6, the total independent number of real asymmetric tensor of rank 2. And here is the question on analytic function. So first you should know the condition for that. Using the two functions vx comma y, ux comma y, f of z, you can just evaluate the equations. The answer for this question must be, you must get the analytical for this function. The answer must be option 3. The value of integral dz by z, where c is a unit circle with radius origin as its center and the integration is done in a clockwise path. So the answer for this question very easy, you can easily solve it. 7th, that is B, minus 2 pi I. The number of independent parameters of the group O3 and SU special unitary group 2 are respectively. The answer is 3, 3. Number of independent parameters of group 3 and SU2. Any Hermitian 2 cross 2 matrix H can be expressed in terms of 2 cross 2 identity matrix I and 3 poly sigma matrices. So where this Hermitian 2 cross 2 Hermitian matrix is there, and the poly sigma matrices has been given. So the Hamiltonian H is Hermitian is represented with this equation. So the option D is correct. A0, AX, AY, AZ are all real. So a condition for Hermitian must be the real values. One of the eigenvalue of the matrix e to the power A is e to the power alpha, where here e to the power A is there. So the value of A has been given. Just you can find out the eigenvalues of this matrix, then the eigenvalue of e to the power I you can get. So the correct answer is option A, 1. 3 fair coins are tossed together. Find the probability of getting 1 head and 2 tails. So here the answer is 3 by 8. 3 fair coins has been used and probability of getting 1 head. So outcomes will be head or tail, 2 outcomes. So probability of getting 1 head and 2 tails is 3 by 8. Given the matrix, what is the value of determinant of e to the power A? So determinant is always what the diagonal elements, 1 minus lambda if you take cube, so 1 minus lambda cube you will get. So the answer will be B here. E, value of the determinant is going to be only exponential E. A particle thrown upward from Earth's surface reaches a height of 100 meter and returns back. The acceleration of the particle at its highest point of reach, H as highest point of reach, has the value option D, particle thrown upward from Earth's surface. So the next will be 14th question. Suppose a radius of Earth were to shrink by 1%, its mass remaining the same. The acceleration due to gravity would be that is increased by 2%. If the differential cross section in scattering is equal to a square, where a is a constant, then the total cross section will be option D, 4 pi a square. The center of mass of an L-shaped uniform wire as shown in the figure with OA equal to and OB equal to L is at so the 16th one will be option B. If the Lagrangian of a mass m is given by L equal to half m x dot square plus xf, f being a constant, then x of t can be obtained in terms of constant c1 and c2. 17, that is option C, c1 plus c2t plus f by 2m t square. A body of mass m moves in a circular orbit of radius r in a potential v of f equal to minus k by r, where k is a constant, then its orbital angular momentum over the center of the circle is option C, root RKM. Identify the correct Hamiltonian equation of motion from the following. So the 19th one is you should go through the formulas. Qi dot dou h by dou pi, pi dot equal to minus dou h by dou qi. So you have to read the theory part. If the potential energy of a body is given by this, the point of stable equilibrium is given by option B, x equal to 2. A rigid body consisting of three particles A, B, C is constrained such that A, B are rigidly fixed to be at rest. Which of the following statements correctly describe the behavior of C? If you read the options, you will come to know the answer will be B. C can move on the circumference of a circle of constant radius with line joining AB passing normally through the center of the circle. If the motion of planet M around the Sun is treated as a two-body problem, T the time period of revolution, A the semi-major axis, G the gravitational constant, then the exact form of the third law of Kepler, here the option will be C. The eigenvalue of the small oscillations of a system having the Lagrangian given by L equal to half m x dot square plus y dot square are the option A. Two masses of value m that are moving towards each other with equal speeds of value 0.6 c collide head on and sticking together from a bigger particle of mass m. The value of m is equal to option B, 5 divided by 2 m meter. Charge q is uniformly distributed in a sphere of radius r. Divergence of an electric field E inside the sphere is 25B, 3q r cube, 3q by r cube. So the 26th, given below are two vectors. Find out which of them can be a magnetic field vector. So here two options are there. So among these two, the correct option is 26B. Second is true, first one is false. At the interface between two dielectric, the normal component of the electric field satisfy option A, epsilon 2 E 2n minus E1 E1n. A charge q is placed at A, B between two right angled grounded conducting planes. Then the image charges and their locations are. So charge q is placed at A, B. The option correct option is B. Okay. Then electric dipole moment of HCl molecule is 1 d by the electric field due to this dipole at a distance of 100 angstrom from the center of HCl molecule on the line joining H and Cl ions is, that is option C, 6.6. Linear Wheeler potentials are the vector potential due to moving point charge, scalar potential due to and scalar potential, or vector and scalar potential due to a moving point charge. So D is the correct, vector and scalar potential due to a moving point charge. Electric fields associated with the two electromagnetic waves are given in ratio 3:2. Then the energy transported per unit area per unit time by these waves are in the ratio option B, 9:4. If the electric and magnetic vectors of a plane electromagnetic wave are along root 3 by 2 I cap plus 1 divided to j cap and opposite direction, then the propagation takes place along Option C, K cap. A dipole moment P is placed in an electric field E naught cross I cap, then the force experienced by the dipole is equal to the B, Px E naught I cap. The magnetic field at the center of a square loop of wire having side A and carrying current I is given by, here none of them are correct, so just you can leave that, or you will get the grace mark. Energy eigenvalue of a particle of you should not leave any of the questions, just you can mark, but you will get the grace mark for this. Eigenvalue of a particle of mass m confined inside a one-dimensional box of length L are given by, so this is the general equation. If you see in quantum mechanics, energy eigenvalue usually that is option C, h square pi square n square dot 2m L square. The ratio of the wave number of first Balmer spectral line of hydrogen to that of the second line Balmer line is obviously that here also none of them is correct, you will get the grace mark. The probability current density for wave function psi of r e to the power I k r divided by r k is the real constant as the magnitude, that is the option B, 1 divided by r square h cross k divided by m. Denote a set of mutually orthonormal states. The norm of the state, that is option D, root of all a square b square c square t square. The commutator x square p x square is equal to that is 2i h cross x cap p x cap plus p x cap x cap. Trace of the matrix where alpha, x and beta denote direct matrices and is given by option A, 0. Then let psi of x be an arbitrary wave function of a physical system. Let h cap Hamiltonian of the system with its lowest eigenvalue denoted by E naught. Then the option 41 option for, so this D is correct, option D, greater than or equal to E naught. A quantum system is in the state ket of psi 1, psi 2, psi 3, where psi 1 is our orthonormal state. The probability amplitude for the system to be in the state is 42, B option, 1 by root 2. Which of the following is a possible eigenvalue of operator? Are components of the orbital angular momentum operator. 43, the option B, 4h cross square. A two-level quantum system has energy eigenvalue in terms of the Pauli matrices. Option D is the correct, E naught I plus E1 sigma z. A three-dimensional harmonic oscillator is the thermal equilibrium with a heat bath at temperature T. The average total energy of the oscillator is always option B, 3 kT, three-dimensional. The number of ways in which 5 identical bosons can be distributed in 4 states is that is option D. So the equation of state of a gas with internal energy U is given by PV equal to 1 by 3U. Then the corresponding equation for the adiabatic process is option C, PV to the power 4 divided by 3 equal to constant. Suppose we have two non-interacting identical bosons, both of mass m, in one-dimensional infinite square well potential in the range. Other is in the first excited state is given by. Among all the 4 options, the correct option for this is C, psi x1 x2 root 2. The partition function for a photon gas is given by ln z. The internal energy you have to calculate using this internal energy U, the relation between internal energy and partition function. 49 D. Average energy of an ensemble of gas molecule in equilibrium is given in terms of partition function Z by that is A minus dou ln Z by dou beta. So these are the 50 questions. Just we have tried to find out the answer, but in the next video we will try to find out the remaining answers for the 50 questions. So thank you for watching.